Alright, let's go. Number 10. But before I tell you the 10 ways the universe is going to die, I want you to sit with one fact that most people spend their entire lives avoiding. Everything ends. Not just you, not just the people you love, not just our species, or our planet, or our sun. Everything. The stars, the galaxies, the atoms themselves. The universe had a beginning 13.8 billion years ago, and it will have an end. And unlike your own death, which is at least softened by the knowledge that the world continues after you, the death of the universe is final in a way that nothing else can ever be. When the universe dies, there is no after. There is no one left to remember. There is no world that continues. There is only the end. Physicists have spent decades working out exactly how this will happen, and what they have found is that there is not one way the universe might die. There are many different scenarios based on different properties of dark energy, different behaviors of matter, different possibilities for the fundamental laws of physics. Some of these deaths are slow, unfolding over timescales so vast they make the current age of the universe look like a single heartbeat. Some of them are sudden, capable of arriving without any warning at all, at any moment, including this one. This is a list of 10 of them, 10 ways the universe and everything in it will one day come to an end. Every scenario on this list is taken seriously by professional cosmologists. Everyone is grounded in real physics, and everyone, in its own way, is more disturbing than the last. By the time we reach number 1, you will understand why some physicists, when they follow the mathematics to its conclusion, quietly stop working on this particular problem. Because there are some answers that, once you have them, you cannot put back. So let us begin. Number 10. Heat death. The slow fade into eternal, perfect nothing. This is the death that most physicists consider the most likely. It is not dramatic. It is not violent. It is in some ways the most horrifying of them all, precisely because of how gentle and how absolute it is. To understand heat death, you have to understand a concept called entropy. Entropy is, roughly, a measure of disorder. And there is a law of physics, the second law of thermodynamics, which states that the total entropy of the universe always increases. Order always decays into disorder. Concentrated energy always spreads out. Hot things cool down. Structured things fall apart. And this process only ever runs in one direction. It never reverses. Right now, the universe is full of order. Stars are burning, concentrating energy and releasing it. Galaxies are structured. Matter is organized into complex forms, including living beings capable of thinking about the universe they live in. All of this order exists because the universe is not yet at maximum entropy. There are still gradients, still differences, still concentrated pockets of energy that can be used to do work, to build structure, to sustain life. But every second, the total entropy of the universe rises. Every star that burns spends some of the universe's remaining order. Every process that happens moves the cosmos one step closer to a state of maximum entropy. And when the universe reaches maximum entropy, something final happens. Everything stops, not because of a catastrophe, because there is no longer any difference anywhere. Every star has burned out. Every bit of energy has spread out evenly across all of space. There are no more hot places and cold places, no more concentrated energy to power anything, no more gradients to drive any process. The universe becomes a uniform, cold, thin soup of particles spread evenly across an incomprehensibly vast space at a temperature just barely above absolute zero. And in that state, nothing can ever happen again. No star can form, no life can exist, no process of any kind can occur, because every process requires a difference in energy, and there are no differences left. The universe reaches a state of perfect, uniform, eternal equilibrium, and it stays there, forever. This is heat death, and the horror of it is not violence. It is the opposite. It is the total, permanent, absolute cessation of all events. A universe that continues to exist, technically, but in which nothing will ever happen again, for an infinite amount of time. The ultimate silence. The end of change itself. This will take an almost unimaginable amount of time, numbers with hundreds of zeros, but it is, according to most cosmologists, where we are headed. The universe is slowly, inevitably, running down, and at the end of that long decline is a cold, dark, eternal stillness from which nothing will ever emerge. Number 9. The Big Rip. The death where dark energy tears everything apart. We talked about heat death as a slow fade. The Big Rip is the opposite. It is a death by violence, driven by the most mysterious force in the universe, dark energy. Dark energy is the force that is causing the expansion of the universe to accelerate. Right now, it is pushing galaxies apart, gently but relentlessly, faster and faster over time. We do not fully understand what dark energy is, and that lack of understanding is exactly what makes the Big Rip possible. Here is the scenario. If dark energy is not constant, if it grows stronger over time, then its effects will become progressively more extreme. Right now, dark energy is only strong enough to push apart the largest structures in the universe, the distant galaxies. Gravity still easily holds together galaxy clusters, individual galaxies, solar systems, planets, and of course, the atoms that make up everything. But if dark energy strengthens, that changes. As it grows more powerful, it begins to overwhelm gravity at smaller and smaller scales. First, it tears apart galaxy clusters, ripping them into isolated galaxies. Then, it tears apart the galaxies themselves, scattering their stars into the void. Then, it rips apart solar systems, pulling planets away from their stars. Then, it tears apart the planets themselves, and it does not stop there. In the final moments of the Big Rip, dark energy becomes so overwhelmingly powerful that it overcomes even the forces that hold atoms together. Molecules are torn apart, then atoms, then the nuclei of atoms, then the fundamental particles themselves are pulled apart, until nothing is left connected to anything else. The very fabric of space-time is stretched to infinity, and the universe ends, not in silence, but in an act of total, universal disintegration. The truly disturbing part of the Big Rip is the timeline of the final moments. In the last minutes and seconds before the end, the destruction accelerates catastrophically. The Milky Way galaxy would be torn apart in the final 60 million years. Planetary systems would be ripped apart in the last few months. Planets would explode in the final 30 minutes, and atoms themselves would be shredded in the last fraction of a second. Whether the Big Rip happens at all depends on the true nature of dark energy, which we do not yet understand. Current observations do not definitively rule it out. If dark energy behaves in one particular way, the Big Rip is not just possible, it is inevitable, and every atom in existence, including the ones that make up you, would eventually be torn into nothing. Number 8. Vacuum decay. The death that could already be on its way. Of all the ways the universe might die, this is the one that should genuinely frighten you, because unlike the others, which unfold over timescales of billions or trillions of years, vacuum decay could happen at any moment. Including right now, including while you are watching this, and you would never see it coming. To understand vacuum decay, you have to understand a concept from quantum physics. Empty space, the vacuum, is not truly empty. It has energy, it has properties, and crucially, it has a state. Physicists believe that our universe's vacuum is currently in a stable, low-energy state. But there is a disturbing possibility. What if our vacuum is not in the lowest possible energy state? What if it is merely in a state that appears stable, but is actually only metastable, like a ball resting in a small dip near the top of a hill, rather than at the bottom of the valley? If that is the case, then it is possible for the vacuum to spontaneously decay to its true, lower energy state. And this could be triggered by a random quantum fluctuation anywhere in the universe at any time. Here is what would happen. In some random point in space, a tiny bubble of true vacuum would form. Inside this bubble, the laws of physics would be different. The fundamental constants would have different values. Atoms as we know them could not exist. And this bubble, once formed, would expand outward at nearly the speed of light, converting everything it touches into the new, lethal state of vacuum. Because the bubble expands at almost the speed of light, you would have no warning. No advanced signal could outrun it. The bubble would reach you at essentially the same instant you could theoretically see it coming. One moment, everything would be normal. The next moment, you, the Earth, the solar system, and eventually the entire observable universe would simply cease to exist in any recognizable form, replaced by a region of space where the physics that allows for matter, chemistry, and life is no longer possible. And here's the part that keeps some physicists awake. Studies of the mass of certain fundamental particles have suggested that our vacuum may indeed be metastable rather than perfectly stable. This is not confirmed, but it is not ruled out, which means that somewhere in the observable universe, or beyond it, a bubble of true vacuum may have already formed. It may be expanding toward us right now, at the speed of light, silent and invisible. And we would have absolutely no way of knowing until the instant it arrived and everything ended. Number 7. Proton decay. The death where all matter dissolves. Everything you have ever seen, touched, or been made of is built from atoms, and atoms are built from 3 kinds of particles: electrons, neutrons, and protons. The proton in particular is one of the fundamental building blocks of all matter. Every atom in the universe has at least one. For a long time, physicists believed the proton was completely stable, that it would last forever, that, unlike many other particles which decay into smaller particles over time, the proton would simply persist, unchanged, for eternity. But some theories of physics predict that this is not true. They predict that the proton, given enough time, will eventually decay. It will fall apart into smaller particles, and if this is true, it has a horrifying consequence for the long-term future of the universe, because if protons decay, then all matter has an expiration date. The timescale involved is almost beyond comprehension. Protons, if they decay at all, would have a half-life of at least 10 to the power of 34 years. That is a 1 followed by 34 zeros, an amount of time so vast that the current age of the universe is nothing in comparison, less than a rounding error. But given enough time, and in the death of the universe, there is always enough time. Every proton in existence would eventually decay. And when protons decay, atoms fall apart. Matter, as we understand it, ceases to exist. Every star that has burned out and become a cold remnant would slowly dissolve. Every planet, every dead sun, every scrap of leftover matter in the entire universe would gradually evaporate into a thin haze of increasingly simple particles. In this scenario, the universe of the far future contains no matter at all, no atoms, no stars, no planets. Just a thin, expanding soup of the most basic particles, drifting apart forever. All trace of the structures that once existed, including everything and everyone that ever was, erased at the most fundamental possible level. Not just dead, dissolved, as if matter itself had never been permitted to last. Number 6. The Black Hole Era, the age when only monsters remain. Let us follow the timeline of the dying universe further into the future than the mind can easily grasp, long after the last star has burned out, long after the galaxies have gone dark. There comes an era when the universe is dominated by a single kind of object, black holes. In the far future, after all the stars have died, the universe will be populated by the cold, dark remnants of dead stars, by drifting planets frozen to near absolute zero, and by black holes. And the black holes, being the objects with the strongest gravity, will slowly consume much of what remains. They will pull in the dead stars, the frozen planets, the scattered debris. Over unimaginable timescales, they will grow, merge, and come to dominate the cosmos. This is the black hole era, a universe consisting almost entirely of black holes, separated by vast and growing distances, in a cold and lightless void. The black holes would be the last great structures in existence, the final monuments of a universe that once blazed with stars and teemed with life. But even the black holes do not last forever. Because of a process discovered by Stephen Hawking, black holes are not truly permanent. They very slowly emit radiation, now called Hawking radiation, and over incomprehensible spans of time, they lose mass. They evaporate. A black hole the mass of our sun would take longer than 10 to the power of 67 years to fully evaporate. The largest supermassive black holes would take even longer, up to 10 to the power of 100 years, but eventually, they too will die. Each black hole, in the final moments of its evaporation, will end in a burst of radiation. And when the last black hole in the universe evaporates, when that final flash of energy fades into the dark, the last significant structure in the entire cosmos will be gone. The universe will contain nothing but a thin, cold, ever-thinning fog of radiation and stray particles, drifting through an endless dark forever. The black hole era is the universe's long twilight, and its end is the moment the last monster dies, leaving behind a darkness with nothing in it at all. Number 5. The Big Crunch, the death where the universe collapses back in on itself. So far, most of the deaths we have discussed assume the universe continues expanding forever. But there is another possibility. What if the expansion stops? What if it reverses? This is the Big Crunch. And it is, in a sense, the mirror image of the Big Bang. Here is the scenario. Right now, the universe is expanding, and that expansion is accelerating, driven by dark energy. But what if dark energy is not constant? What if, in the far future, it weakens, or even reverses, becoming an attractive force instead of a repulsive one? Then gravity, which has been quietly losing the battle against expansion, would finally win. The expansion of the universe would slow, then stop, then reverse, and the universe would begin to contract. At first, the contraction would be slow, almost imperceptible, but like a ball thrown into the air that pauses at its peak and then falls faster and faster, the collapse would accelerate. Galaxies that had been rushing apart for billions of years would begin to rush together. The cosmic background radiation, which is now a cold whisper, would grow hotter as the universe shrank. The sky would begin to glow, then blaze, then become an inferno. In the final stages of the Big Crunch, the entire universe would compress into a smaller and smaller volume, growing hotter and denser with every passing moment. Galaxies would merge, stars would be torn apart by the rising heat before they could collide. The temperature would climb toward infinity, matter itself would break down, And finally, everything, all the matter and energy in the entire universe, would be crushed back into a single point of infinite density, a singularity, the same kind of state from which the Big Bang emerged. The universe would end the way it began, crushed into a point smaller than an atom, at a temperature and density beyond anything that can be described. Every galaxy, every star, every atom, compressed into nothing. And here is the strange, haunting possibility that some physicists have raised. What if the Big Crunch is not the end, but a transition? What if, at the moment of maximum compression, the universe bounces and a new Big Bang begins, giving birth to a new universe, a cosmos of endless cycles, each one ending in a crunch and beginning in a bang, forever? We would be one cycle among infinitely many, and the death of our universe would be nothing more than the labor pains of the next. Number 4, the degenerate era, the long, cold death of starlight. Let us return to the slow death and look closely at one particular phase of it, because the death of the stars is not a single event. It is a long, drawn-out process, spanning an era so vast that it deserves its own place on this list. Right now, we live in what cosmologists call the stelliferous era, the age of stars. The universe is full of them, blazing across the sky, forging heavy elements in their cores, warming planets, and making life possible. This is the golden age of the cosmos, and we are living in it, but it will not last. Star formation is already slowing down. The universe is using up its supply of the gas that forms new stars, and eventually, in the far future, the last star will be born. It will burn for a while, and then it too will die. After that comes the degenerate era, an age defined not by living stars, but by their corpses, white dwarfs, the cooling embers of sun-like stars, neutron stars, the ultra-dense remnants of massive stars, black holes, the final graves of the most massive stars of all. And drifting between them, cold dead planets and failed stars called brown dwarfs that never ignited at all. In the degenerate era, the universe grows dark. The brilliant light of the stelliferous era fades. The sky, to any observer that might still exist, becomes black, punctuated only by the faint cooling glow of stellar remnants, growing dimmer with every passing eon. The universe becomes a graveyard, filled with the frozen corpses of the stars that once lit it, and this era lasts an almost unimaginable length of time, far longer than the age of stars. The universe will spend the overwhelming majority of its existence not as the bright living cosmos we know, but as this cold, dark, dying graveyard. We happen to live in the brief, brilliant morning of the universe, but the universe's true nature, across the vast sweep of its future, is darkness, and that darkness is coming. Number 3, the dark era, the final, absolute blackness, after the degenerate era. After the last stellar remnants have faded and the protons have decayed and the black holes have evaporated, the universe enters its final phase, the dark era. In the dark era, there is nothing left. No stars, no planets, no black holes, no atoms, no matter of any recognizable kind. The universe consists of nothing but a thin, cold, ever-expanding fog of the most elementary particles. Photons of light stretch to wavelengths longer than galaxies, stray electrons and their antiparticles, neutrinos drifting through the dark. All of it spread so thin, across a space so vast and still expanding, that these particles almost never interact with one another. They drift alone, in the dark, separated by distances that grow larger with every passing moment, forever. This is the true, final state of the universe in most models, not a dramatic ending, not a violent collapse, just an endless, cold, black, silent expansion. A universe that continues to exist, technically, but that contains nothing, does nothing, and means nothing. An infinite darkness, growing infinitely emptier, for an infinite amount of time. There is no clock in the dark era, because nothing ever changes. There is no such thing as an event, because nothing ever happens. Time, in any meaningful sense, ceases to exist, because time is measured by change, and there is no change left. The universe becomes an eternal, frozen, lightless void, and it stays that way, forever, with no possibility of anything ever occurring again. This is where most roads lead. Follow the physics of our universe far enough into the future, and this is what you find at the end. Not a bang, not a crunch, just an endless expanding darkness, containing the scattered, inert remains of everything that ever existed, drifting apart forever in a cold that approaches, but never quite reaches, absolute zero. Number 2, the false vacuum, and the possibility that reality itself is a lie. We touched on vacuum decay earlier, as a sudden death that could arrive at any moment, but there is a deeper and more philosophical horror hidden inside that idea, and it deserves its own place near the top of this list. The concept is called the false vacuum. And what it suggests is that the entire universe we live in, all of physics, all of chemistry, all of the laws that govern reality, may be built on a foundation that is not truly stable, that we are living inside a temporary configuration of reality, a configuration that looks permanent, that has lasted for 13.8 billion years, but that is, at its core, a lie. If our universe is in a false vacuum state, then everything we know, every law of physics we have ever discovered, every constant we have ever measured, is not fundamental. It is merely the way things happen to be in our particular, temporary, metastable configuration. The true underlying reality is different, and at any moment, the universe could collapse into that true state, erasing everything we know and replacing it with a physics in which we could not exist. This is more than just a way the universe could die. It is a statement about what the universe fundamentally is. It suggests that the stability we take for granted, the reliability of the laws of nature, the very consistency of reality, may be an illusion, a comfortable illusion that could shatter at any moment. And the truly disturbing implication is this: if the false vacuum is real, then the universe has been living on borrowed time since the moment of the Big Bang. Every second that passes is a second in which the collapse has not yet happened, but statistically, given enough time, it will. It must. The only question is when. And because vacuum decay would arrive at the speed of light, without warning, we will never know it is coming. There will be no final moment of awareness, no chance to say goodbye. Just an instant, indistinguishable from any other, in which everything that is, abruptly and permanently, stops being. Number 1, the death of time itself, and the answer that physics refuses to give. We have talked about the death of stars, the death of matter, the death of black holes, the death of light, but there is one final death that underlies all of them, and it is the most disturbing of all, because it is the death of the thing we least understand, and the thing we most depend on to make sense of everything else, the death of time. Everything we have discussed on this list, every scenario, every ending, assumes that time continues, that there is a future in which these things happen. Heat death happens in the future, the Big Rip happens in the future, even the endless nothing of the Dark Era is something that persists through time. But what if time itself ends? In the deepest reaches of theoretical physics, in the study of what happens at the very end of the universe, some physicists have confronted a possibility that is almost impossible to put into words. In a universe that has reached its final state, whether heat death or the Dark Era, or any of the truly final scenarios, a strange thing happens to time. Time is defined by change. We measure time by things happening. A clock ticks because its gears move. Your life passes because events occur, one after another. Time, in physics, is deeply connected to entropy, to the movement of the universe from order toward disorder. The reason we experience time as flowing from past to future, rather than the other way around, is because entropy increases in that direction. But at the end of the universe, when entropy reaches its maximum, when everything is uniform and nothing can change, entropy stops increasing. And if entropy stops increasing, the very thing that gives time its direction, and perhaps its existence, is gone. In a universe of perfect, final, maximum entropy, nothing changes, ever again. And in a universe where nothing changes, there is no meaningful way to say that time is passing at all. There is no next moment, because every moment is identical to every other. There is no flow, because there is nothing to mark it. Time, in any sense we can comprehend, simply ceases. This is the final death, not the death of stars or matter or light, but the death of change itself, the death of the future. The moment after which there is no after. The universe does not end in fire, or in cold, or in darkness alone. It ends in a stillness so complete that the concept of ending no longer applies, because ending requires time, and time is precisely what has died. And this is where physics stops. Because the questions that lie beyond this point are questions our science cannot answer. What does it mean for time to end? Is a frozen, eternal, changeless universe the same as no universe at all? If nothing can ever happen again, in any sense, forever, then is there any meaningful difference between that state and non-existence? The mathematics gives us the state, but it cannot tell us what that state means, and it cannot tell us whether anything in any form could ever come after. And that senior astronomer, the one some of you have asked me about, the one who allegedly said, off the record, that he wished we had never looked, when he said it, this was the road he had followed to the end. Not the beauty of the stars, not the wonder of the galaxies, but the long, cold logic of where it all leads. Because once you understand how the universe dies, once you follow the physics all the way to the death of time itself, you carry that knowledge with you, in every sunrise, in every night sky, in every moment of every ordinary day. The knowledge that all of it, every star and every atom and every person, is a brief, bright flicker in the middle of an ending that has already begun and that cannot be stopped. The universe is dying. It has been dying since the moment it was born, and we are living, all of us, in the fleeting, precious, impossibly brief window of light before the dark. That is not a reason for despair. It may be the opposite. Because if everything ends, then everything that exists right now, this moment, this breath, this fragile flicker of existence in the vast dark, is rarer and more precious than any treasure the dying universe will ever produce again. If this video changed the way you see the time you have, then you should know there are older ideas about the fate of everything, older answers that most people have never heard. I made a video about those. It is on the screen right now. If this one kept you up, that one will keep you up longer. And if you want to be here for whatever time we have left, hit subscribe. Because the universe may be dying, but it is not dead yet, and there is still so much left to see. Alright, see you in the next one.